string class supports a wide variety of assignment operations. And in this demonstration, we're using two empty strings to begin with, and then we assign the first string specific using prototype of a string literal specific content. So of course this assignment would work. You can also assign a single character to the string. So now the second string becomes a string of one character alone. So here we can test. I'm using assert macro, which comes from cassert, which should always be your first include if you're using it. And it simply terminates the program, throws an exception if this condition is not true. So I'm just asserting that this condition is true without the need to print anything on computer screen to verify that this is the case, that this is true condition. Of course, strings can be assigned one to another, and for constructors that we've seen on the previous page, there is a matching set of assign functions which take a prototype and use equivalent parameters to extract information from the prototype. So here, of course, we're saying that we want only 4 characters, and this will verify that that is true after using this type of assignment. So this is not an assignment operator anymore, but this member function comes together with this to match existing constructors, which is very convenient. Another example, again matching one of the constructors that we've seen on previous page, is to take the string and assign a number, a desired number of characters to it and specify the character. So here again we can assert and can verify that the content of this string is 6 lowercase a characters. And here's the description of another assignment where we take the initial position and we specify the length to extract from another string. So we provide string 1 as a prototype, and we're assigning from the second position to the 5th position, and we are assigning it to another string, now verifying it that it was true. And the idea is that this is position 0, this is position 1, this is position 2. So here we specify position 2, and if the desired length of the portion of the prototype string happens to overrun the length of available characters, this length is simply truncated to the available characters. So this is why this is the fragment that this assignment is extracting from the prototype, and that's why we're testing it like this. So just very handy, very consistent, and meaningful in many situations when you are manipulating characters. This is the range of things that you can do with respect to assignment operations. Another very typical set of functionality is appending content at the end of the container. So again, using very similar to the previous assignment, which updates the content. Here we only appending it. So again, we start with 2 empty strings to begin, and we're appending using plus equals overloaded operator, or concatenating a single character, or concatenating strings altogether. Again, this is examples of appending from the prototype, and so here we have the outcome of the previous operation. And then we're appending a certain number of characters, so we're appending more characters to existing, and then we're using another string as a prototype, which we see was right here, formulated right here, so it's Freda, and here we're appending again extraction of the from position 2 to the length of 5, but we run out of characters at 3 characters. That's why we're appending EDA. So EDA is getting added to this example. Okay. Individual character access can be done simply with using square bracket notation, which is another operator which is overloaded for strings, and we can specify the index. Again, we begin here with string, which is set equal hello. Then we say that let's extract the character from the 4th position. So we are extracting a character from here, and we're saving this character as just a separate variable. Okay, so I'm expecting that this is position 0, 1, 2, 3, 4. So this actually is a position of lowercase character O. So CH should be getting this character. Then we go back to a string that we already populated, and we'd like to position, I'd like to go to position 0, which is this character, and update it with new character. When we discuss in the next section operator overloading, and we'll use examples that provide access to overload index or subscript operator, you will see the difference between const and non-const version of square brackets. Of course, in any content, in any context where we're just getting information from the container, in our case string of characters, we're just using constant version of this subscript, which requires only read-only access. But when we're using it on the left-hand side of an assignment and trying to modify it, this is something that we refer to non-const version of subscript operator. Again, examples will follow in the next section of the course. So here, this is something that is entirely responsibility of a programmer to make sure that the indices that we use, just like with all other containers, are within the acceptable range. So right here, HELLO, all of these characters, there are 5 characters, and of course the last character is at the index 4. So index 5 refers to a non-existing character. So remember that null terminating character, which automatically appended to C string, is ignored by the string organization. So this would be, sometimes this can cause unpredictable results, and sometimes it will break the program, cause memory access violation. Sometimes it can go completely unnoticed if that memory still belongs to your program, and your CPU will not be able to detect anything, any wrongdoing. So of course, attempts to do something like this may cause unpredictable behavior in the program. If you'd like to throw an exception as a result of this invalid out-of-range access to the content of the string, it's possible to use, instead of square brackets, to use at member function and specify this position right here. In this case, if position 5 is out of range of accessible characters, out of range exception will be thrown, and you'll be able to catch that exception as a result of this incorrect access to the content of the string. Of course, when this is a hard-coded position, it's kind of silly and doesn't look very convincing. But if this was a variable and it would depend on other parameters in the program, then of course sometimes it's possible that some kind of logical errors or miscalculations could be causing out of range access to the string, and then this becomes very, very usable type of exception. So you can remember, you can go back to this here, and there will be examples if you browse through element access and check the documentation for at. You'll see that there are examples of using this specific type of function for you to explore.